All right, in this transformations review practice, I want to go over some more specific details of transformations and how you might see them. And then we're also going to just go through and do a bunch of problems where we identify what transformations are happening. So first and foremost, just a couple more notes. I noticed that some people were having some trouble identifying inside and outside of certain function families. And so this would be a great time to review function families as well. So if, for example, we had a quadratic function, so if I had, let's start off with a quadratic. So the typical parent equation for a quadratic function is x squared. And so basically what would happen is if you had something being done inside of an x squared function or a quadratic function versus if you had something being done on the outside. So an example of that would be if we had a 4x squared. That 4 is just multiplying in front of that x squared. It's on the outside. It's a vertical change. As opposed to if you had 4x squared on the inside, that would be a horizontal change, okay? So that would be one example of it. You could also have, if we had a cubic function, the parent equation of that is an x cubed. And so if you had something happening on the outside of your cubic function, you would have like x cubed minus 5. That would be different. That's vertical because it's just tacked on to the end than if you had x minus 5 cubed, like that. All right. If we did a higher polynomial, so let's say we had like x to the ninth or something like that, and we wanted to, let's see, do a reflection or negative. Vertically, it would be minus x to the ninth. Horizontally, it would be minus x to the ninth, like that. Okay, so this would be a vertical flip, so a reflection over the x-axis. This would be a reflection over the y-axis, a horizontal flip. This would be down 5. This would be right 5. This would be a vertical stretch by 4. This would be a horizontal shrink or compression by 1/4. All right, let's do, what's after a higher polynomial? Let's do an absolute value one. I don't think that's technically in the correct order, but absolute value. So if we had an absolute value, the typical absolute value looks like this. Let's work with if I did two transformations. So vertically, let's say that we multiplied by 1/3 in the front, and then we also moved it up 2. So this is a vertical, shrink by 1/3, and then it moves up 2. Both of those things are happening on the outside of the function. Now, if they were going to both happen on the inside, so if I had a 1/3 inside and then an x plus 2, that's all inside of my absolute values. So it doesn't matter if there's like an extra set of parentheses going on. You just have to pay attention to what was in your original parent equation. And then if is it all inside your absolute value symbol, then yes. So this 1/3 is a horizontal stretch by 3, and then this moves left 2. Okay. Typically, if you have, this is kind of an important detail, but if you have a horizontal stretch, whoops, a horizontal stretch or shrink happening. So let's say that you're multiplying by some value c, and then you also have left or right. The left or right part goes in parentheses, so like it'd be x plus or minus some number d. And then your horizontal shrink would be happening, shrink or stretch, and then this outside piece right here, this would be whatever your function family is. So like in this scenario, it was an absolute value symbol, but it doesn't necessarily have to be absolute value. It could be like a square root would be around the whole thing. That would be a radical, or it could be the log of all of this stuff. That would be a logarithmic function. All of this stuff is still happening inside of that function, okay? So I just wanted to try and make that a little bit clearer. Let me do another example. So since I just talked about a radical, we'll go ahead and we'll do a radical one next, and then I think I'll have to erase and clear out and try something new. So if you have a radical, this is a typical radical equation. And let's do, let's see, we'll have a negative radical, mix it, nope, and then an x, and then we'll do, let's stick a 2 in front. So that's a reflection and a vertical stretch. Inside, it would look like this, negative 2x. Okay, this would be a vertical stretch by 2 and a reflection over your x-axis because it's a vertical flip. And then inside it would be a reflection over your y-axis, which is a horizontal flip, and then a horizontal shrink by 1/2. Okay, so that's quadratic, cubic, higher polynomial, absolute value, and radical. Go ahead and, oops, I don't care about what color my eraser is, I just want it to be bigger. There we go. Go ahead and we'll look at some of the other ones. I think I just have to still do exponential, logarithmic. All right, so if I had an exponential example, and then we'll do log, and I think the last one is a rational. So after rational, or let's look at exponential first. So an exponential equation, 5 to the x, would be a very typical equation. This could be any number like 8 to the x, 12 to the x, whatever. But if I wanted to work on this equation vertically, so things that would happen to it vertically, I could have, for example, a 1/2 times my 5 to the x, right? The 1/2 is just multiplied right out front, plus 3. That would be a vertical compression by 1/2, and then up 3 inside of your actual equation. If it was horizontal, it would be 5 to the, and then all of that stuff would be up in your exponent because that would be inside of your exponential function. So it would have a 1/2 and then an x plus 3. And then technically it'd be okay if I had more parentheses around here as well, but you don't need them because that's very obviously all up inside the exponent. So that's inside of your exponential equation. This means I'd have a horizontal stretch by 2 and I'd move left 3, okay? Logarithmic, a typical log equation, you could use log or you could use natural log would be the other one. So it'd be natural log of some x value. Vertically, if you did something to that, it'd be, have to be on the outside out here. And the x isn't always technically in parentheses either. Natural log of x could just be like that. But if it's inside, it would be a negative x like that on the inside. And then for rational, a typical rational expression is 1 over x. And you could then, if you're putting stuff on the outside, you could multiply by, let's say, what do you want to multiply by? 2 times 1 over x plus 8. You also might see this as 2 over x plus 8 because, right, this is technically 2 over 1, so I could just multiply across the top and bottom. But the important part is that this 2 isn't down here with this x. It's not inside of my rational expression. It's just multiplying by it. And then if you were looking at, so that's all vertical stuff that's happening. There'd be a vertical stretch by 2 and up 8. Or if it was happening inside of your function, it all has to be down here in the bottom, and it would be 2 and then an x plus 8. This would be a horizontal compression by 1/2 and then left 8. Right? So those are examples of ways that you could see inside and outside of different function families. And now we're just going to look at some generic stuff and be able to identify transformations from the equations. Okay? I actually think I can make this bigger now. There. All right, so for these transformations, I just describe the transformations in order they're being done in the function. I don't necessarily need them to be in order when you describe them for me, just as long as you name all of them. So if we have this negative is outside your function, and so is this 4, so this is a reflection over your x-axis, because remember, that's a vertical reflection, right? Vertical on the outside. And then also you have a vertical stretch by 4. Beautiful. In this next one, I have a 3, but it's definitely inside of my function. So that is a horizontal compression or shrink. You can call it either one, compression or shrink by 1/3. This one I have a 1/2 out front outside, so that's a vertical shrink or compression by 1/2. And then it also has a negative inside, so that's a reflection over my y-axis. Okay. This has got a lot of stuff going on. Okay, so we have a negative out front, so that's a reflection over your x-axis. I have a 1/3 out front, so that's a vertical shrink by 1/3. I have a 1/2 inside of my function. So even though it's not in the parentheses with the x, notice how my f, that's my function. My f contains all of that stuff. So that's how my 1/2 is inside of my function. So that 1/2 inside actually means a horizontal stretch by 2. And then an x plus 1 that's still inside is actually left 1. You could say a horizontal translation, you could say a horizontal shift left, you could just say left 1. Those would all be accurate ways of describing that. All right, let's do a couple more of these. So this one I have a 5 out front, so that's a vertical stretch by 5. And then I have a negative inside of my function that's multiplying, so that is a reflection over your y-axis. Then a 2, so that's a horizontal shrink by 1/2. And then an x minus 4 means right 4. All right, let's do this last one. The negative out front means a reflection over your x-axis. The 2 out front means a vertical stretch by 2. The 8 inside means a horizontal shrink by 1/8. And then the plus 4 tacked on to the end means up 4. Beautiful. We're not going to worry about graphing transformations. Okay, perfect. So I just wanted to make sure that we had gone through and you'd be able to identify transformations, and also if you could maybe like write equations from different transformations, that would be ideal. Okay, so let me know if you have some more questions. Other than that, you have some transformations practice that you can be working on, and I think it would be awesome. Thanks, guys.